Assalamu alaikum guys, welcome to solving solving quadratics with square roots, and this is lesson 8.5. This is a super easy lesson. So you've kind of done it in 8th grade, but we're just going to take it a step further. We're going to apply it to quadratics. So instructions are to solve using square roots, and then also if there are no solutions, then the answer should be no solution. So let's go ahead and go. So you have 3x squared is equal to 27. So the whole point is that you're trying to isolate your x. Now, one of the things that we learned last year is that every square root has 2 square roots, or 2 squares. So in order to isolate my x, the first thing I need to do is get rid of the 3. And between 3 and x squared is multiplication. So the inverse is division. I divide both sides by 3. So it leaves me with x squared is equal to 9. Now, in order to unsquare my square, I need to find the square root of 9. So in this case, x is equal to the positive negative square root of 9. And that's why every square root has 2 squares. So the positive and the negative. Now at this point, 9 is a perfect square. So it's as easy as x is equal to positive and negative 3. So in this case, if you were to rewrite this in standard form, okay, and you were to graph it, the solutions would be 2, a positive 3 and a negative 3. The x-intercepts would be that, okay? So now let's go to the next problem. The next problem is p squared plus 12 is equal to 12. So again, isolate your p, but you need to get rid of the 12 first. So first thing, you go ahead and subtract 12 from both sides. You're left with p squared is equal to 0. And then what is the square root of 0? The square root of 0, and by the way, in a square root of 0, 0 is the only one that is neither positive nor negative because it's a neutral number, right? In this case, the square root of 0 is 0. So p is equal to 0. That means it has only one solution, and it's going to pass or touch the point of origin, okay? So that's a couple of, examples. Let's try a good 4 more so you get a good experience on it. And let's say that we have a squared minus 3 is equal to negative 4, okay? So first thing, I need to go ahead and add 3 to both sides. So add 3, I'm left with a squared is equal to negative 1. And remember, we did say in order to unsquare the a, you need to find the square root of the other value over here. So a becomes the square root of negative 1. Now, if you go back to chapter 1 of last year, what kind of value is this, or what kind of number is this? What is it classified as? There's no possible way that you can get a square root of a negative number. Except when you get to Algebra 2, you'll learn how to do it, and it's called iota. But for the grade level that you're at right now, this is no solution. And if you try to plug it into the calculator, the radical of negative 1, it's going to give you error on your calculator. And the minute you see error, that means that it's not a solution. So in this case, you cannot find the radical of a negative, so your answer is no solution. That means that if this quadratic was graphed, there would be no way that it passes through the x-axis. Okay? Now let's try another one. What if you have 25x squared is equal to 49? So between 25x squared, there's multiplication. Opposite of multiplication is division. So I'm going to divide both sides by 25. So I'm left with x squared is equal to 49 over 25. Now, I know that 49 and 25 are perfect squares, so I'm not going to try to reduce it or turn it into a decimal or anything like that. Leave it as is, okay? So now, in order to unsquare this x, find the square root of the other side. And don't forget, every time that you are doing a square root, go ahead and do plus minus. So 49 over 25. Now, what's the square root of 49? 7. What's the square root of 25? 5. So x is equal to positive negative 7 over 5. So that means that on a graph, okay, this 7/5 is the same thing as 1 2/5. So it's going to pass through positive 1 2/5, sorry, positive 1 and 2, yeah, positive 1 2/5 and negative 1 2/5. Okay, that's what it means. So this one has two solutions. All right. Now, let's go ahead and do the next one. 121n squared is equal to 225. Again, same thing as the previous problem. Divide by 121 on both sides. And if you know your square roots or your square tables, you would know that 225 is a perfect square and 121 is a perfect square as well. So in this case, n squared is equal to 225 over 121. And then again, in order to unsquare your n, go ahead and find the square root of the other problem. And don't forget positive, negative, and it's 225 over 121. So in this case, n is equal to positive, negative. The square root of 225 is 15. And then the square root of 121 is 11. So this also has two solutions, okay? Now the last one on this part, let's say that we have, for example, 49b squared is plus 64 equals 0. So first thing I need to do is go ahead and move the 64 to the other side. And the only way I can do that is if I subtract 64 to both sides. So I'm left with 49b squared is equal to negative 64. And you can probably already see, well, Missy, then I'm going to have a negative on the other side. There's no way that I can find the radical of a negative number. You still show me the math. And in this case, you end up with sorry, it should have been, sorry about that. I started getting to the final answer because I'm talking with you all. But negative 64 over 49. And then remember, in order to unsquare it, b is equal to the radical of negative 64 over 49. And in this case, remember, you cannot find the radical of a negative number. So at the end, this is also a no solution. And basically, this is the gist of the lesson, guys. So I gave you some problems. I know that it's going to take less than 15 minutes to do if, you follow these steps. Now, this part, the only reason I'm showing it to you is because I want you to have it in your class notes, especially when you go into Algebra 2, so you can know how to solve when there is solutions, but they're not perfect square roots. So most likely what they'll tell you is to the nearest hundredth. Okay, so you're still going to be using square roots, only it's to the nearest hundredth. So this is just for your notes, not for the lesson itself. So let's go ahead and let's say that you have 2x squared minus 10 is equal to 6. Okay, so first thing is, go ahead and add 10 to both sides. So you add 10, then you have 2x squared is equal to 16. Next step, get rid of the 2. So you're dividing both sides by 2. X squared is equal to 8. Okay, and then how do I unsquare my x? Find the positive negative square root of 8. Now here, because the instructions say to the nearest hundredth, then go ahead and use the nearest hundredth, right? So it's going to be an approximation. So x is approximately positive negative, and when you plug in the square root of 8, you should get 2.83. So this quadratic, if graph, would pass approximately to positive negative 2.83. Now this would be used more for equations or quadratics that you cannot factor easily. This is one way to solve it. So let's try one more, because you're going to need this skill, especially when you get to algebra. Let's say that you have 4x plus 6, and I believe it's x squared. No, it's x plus 6 squared, sorry. So it's 4 parentheses open, x plus 6 squared, and it equals 232. So we're not going to use distributive method, guys. We're not going to do the FOIL. We're not going to do patterns. There's a way to isolate. So between 4 and the parentheses is multiplication. So how do I undo the 4? If I divide this side by 4, I get rid of the 4's. I'm left with x plus 6 squared is equal to, and then what's 32 divided by 4? It's 8, okay? Now, here, remember, just what have we've been doing. When I say, how do I unsquare an x? Go ahead and find the square root. So in order to unsquare this, the x plus 6, okay? In order to unsquare it, go ahead and write x plus 6, and actually you could probably drop the parentheses anyways, is equal to the positive negative square root of 8, okay? So just by doing the square root of the 8, I can, basically this is the math behind it. If I am finding the square root, right? Because that's the next step here. It's the positive negative square root of 8. This square root undoes the square. Okay, so I can drop my x plus 6. That's the mechanics behind it. So now I want to isolate my 6, so what happens? I need to subtract 6. So minus 6, minus 6. So on this side I have x. On this side I have, although negative 6 is secondary, you can go ahead and say negative 6 plus or minus square root of 8. Okay? Now, this has two solutions, but you need to actually get to the nearest hundredth because those are what your instructions are. So you can write two statements now. You can say negative 6 plus the radical of 8 or negative 6 minus the radical of 8. And remember, in the previous problem, the radical of 8 was 2.83, right? So negative 6 plus 2.83 or negative 6 minus 2.83. And if you do the math, go ahead and use your calculator. Negative 6 plus 2.83. It gives you approximately, and in this case you would say x is approximately negative 3.17. And on the other side, x is approximately negative 8.83. So this will not be on your worksheet, guys, but just keep it in your notebook for future reference, inshallah. If you have any questions on the lesson, I think it's pretty easy. Don't hesitate to come to class. You'll have a classwork assignment today, and 15 minutes, you should be able to get it done. So like that, you don't have it added homework for the following week. Assalamu alaikum.